All right, so last class, or a few classes ago, we cut out our circles. You should have 3 different size circles, and we layered them on top of each other. And then making sure that they're folded into quarters, half and half this way. We put a hole through the middle. Use a pen. Okay, put a brad through. And then folded the brad flat. Okay, so, and then we began to talk about how if I put my triangles, the 3 triangles that we cut out, if I put the 90-degree angles all together, and I put them in here, the 90-degree angles all the same direction, but we put the points so that the 90 degrees angles are on the outside, then I have created a 30-degree, 45-degree, and 60-degree angle in quadrant 1. So now we're actually going to go ahead and put those onto a coordinate plane. So same as when we put the brad through the circles, you want to poke a hole through the paper first. Be careful not to poke yourself. And then we're going to reopen the brad, put it through the paper, turn that upside down, and lay it flat. Okay, so now what we have is a coordinate plane with our circles on it. Okay, let's see if I can get this a little, there we go. So now what you're going to do is you're going to take your triangles, and I'm going to start with this triangle. And we talked about how this is a 90-degree angle, so this is a 30-degree and this is a 60-degree angle. So I'm going to put those here, and I'm going to line it up with my x-axis, and I'm going to try to line up these circles as best as I can. And you're going to need 2 different colors for this. So I'm going to use blue and pink to match my triangles. So on the blue triangles, for my 30-degree angle first, I'm going to trace along this edge of the triangle all the way onto the coordinate plane. And then kind of rotating this triangle around, I'm going to do the same thing for the y-axis, lining up my triangle on the y-axis and tracing that edge of the triangle. And then for the negative x-axis, again, kind of just rotating that triangle around, tracing the edge, and the negative y-axis. Kind of rotating the triangle around and tracing the edge. And we're going to do that for all 3 triangles. So now for the pink triangle, I'm going to use the pink highlighter. And this is, as we discussed in class, a 45, 45, 90 triangle. So lining up on the positive x-axis and tracing that side of the triangle, the positive y-axis, and tracing that side of the triangle. Now each time we're doing this, we're tracing what's called the hypotenuse. It's the side that's opposite the 90-degree angle. Hopefully you remember that from geometry. Okay, so that's 2 triangles down. Last triangle is blue. So I'm going to use my blue highlighter again. positive x-axis. Now this is the same shape as our 30, 60, 90 triangle, and it is indeed another 30, 60, 90 triangle, but now I'm tracing the 60-degree angle. So we're kind of using these triangles like a protractor to create our own angles. We're copying the angles. Okay, so now we've traced all three triangles, and we're going to look at some patterns. So for example, if I rotate one of my circles and I line up the blue lines, notice how some of the other blue lines line up as well. Now this is because the angle between my blue lines is 30 degrees. We measured from our x-axis to this first line was 30 degrees, and then to here is another 30 degrees. So this is, between blue lines is a 30-degree angle. So if I wanted to mark all of my 30-degree angles, I also have to mark my axes. So my x-axis and my y-axis give me multiples of 30-degree angles between each blue line. Okay? And let's look at for the pink lines. If I rotate my circle, if I match the pink lines match up, right? Now, the way we created the pink lines is we said, here we have from my x-axis to the pink line is 45 degrees. What about from the pink line to the y-axis? Well, that's another 45 degrees. So really my axes should also be pink. So I just rotated the circle back. It wasn't really necessary. And now I'm going to make the axes also pink. So now notice the axes are kind of purple, the x and y axis. And that's because they are a multiple of both 30, which is pink, 30-degree angles, and blue, I'm sorry, the pink is 45-degree angles. Let me use white out. (45-degree angles), and the blue, which is 30-degree angles. Okay. Now, some things that you might want to notice are that if, for example, I look at just these blue lines here, which both have 30-degree here and 30-degree here on either side of the x-axis, these have the same x value. And so do these, and so do these. Right? So if I were to put a point here, and here, and here, here, and here, and here, these two would have the same x value, these two would have the same x value, and these two would have the same x value. Okay, similarly, if I were to do, for example, a point here, those 2 points would have the same y value. So there's a lot of symmetry going on in this circle. Okay, so how that plays in is that if we look at a circle with a unit or a radius of 1, that 1 is a unit. Okay, so we are going to pretend that our inner circle is our unit circle, but we're going to label the points on the outside so that they're on our graph. Now, to find the value of the points, some of them are relatively easy. For example, if this has a radius of 1, then the point here would be 1, 0. Right? Because if this distance is 1, it's on the x-axis, so the x value would be 1. Similarly, if I were to put the point on the y-axis, this has a distance of 1. So, let's see. The point would be 0, 1. And then on the opposite side of the x-axis, our negative x-axis, negative 1, 0. And on the negative y-axis, we have 0, negative 1. Okay, for the other points, we need to know what our x and y values are, right? And that's where these triangles come in. So, looking at our triangles, I'm going to push the circle aside for a second. Looking at our triangles, let's start with the 45-45 triangle. Let me put this on a whiteboard so that it'll be easier to read. Okay, so if we're looking at the 45-45 triangle, I know that my hypotenuse is 1, these two angles are congruent, so these two sides are congruent. Okay, if I call this side length x, then this also has to have side length x. Then using the Pythagorean theorem, we know a squared plus b squared equals c squared. So that's x squared plus x squared equals 1 squared. Well, x squared plus x squared is just 2x squared, and 1 squared is just 1. So dividing both sides by 2, I get that x squared equals 1/2. And then using the square root property, I have to do a plus or minus. So x is plus or minus the square root of 1/2. Well, x is a distance, so it has to be the positive. So this distance is the square root of 1/2. As mathematicians, we don't like to leave radicals in the denominator, so we're going to rationalize this. And that means writing it as separate radicals. Square root of 1 is just 1, divided by the square root of 2. That still leaves a radical in the denominator. So I'm going to multiply by the square root of 2 over the square root of 2. This is called the process of rationalization. That gives me the square root of 2 squared in the denominator. So x equals 2 in the denominator and the square root of 2 in the numerator. So what we can put on our triangle here is that this side length is the square root of 2 over 2, and this side length is also the square root of 2 over 2. Okay, and now we want to do the same thing for our 30, 60, 90 triangle. So looking at our 30, 60, 90 triangle, and the thing that's special about this is, as we talked about in class, that two of them together make an equilateral triangle. So if this is 1 and this is 1, then this must also be 1. And if this is 2 halves of 1, then these distances, the shortest side of the triangle, must be 1/2. So really we're just looking for the third side, the middle leg. So again, we have our triangle, we have 1, 1/2, and x. Okay, this is a 30, 60, 90 triangle, degrees. So I say x squared plus 1/2 squared equals 1 squared. X squared plus 1/2 times 1/2 is 1/4 equals 1. So x squared, I'm subtracting 1/4 from both sides, equals 3/4. Again, using the square root property, x equals plus or minus the square root of 3/4. Well, it's a distance, so it's not negative. And then again, rationalizing, I get the square root of 3 over 2. Now notice at this point there's no radical in the denominator, so we don't have to continue rationalizing, which leaves us with our longer leg here as the square root of 3 over 2. So going back to our graph, how does that help us? Well, remember we made these angles by tracing these triangles. All right, so using our first triangle with the 30-degree angle, if I were to overlay this, you can see the x value would be square root of 3 halves, and the y value would be 1/2. Let me see if I can get this to focus a little bit better. A little bit better. Okay, so the value of the point here would be square root of 3 over 2 comma 1/2. That's the coordinates. Okay. For the pink triangle, we have x value of square root of 2 over 2 and a y value of square root of 2 over 2. So our point is square root of 2 over 2, comma, square root of 2 over 2. And our third triangle, we have an x value of 1/2 and a y value of square root of 3 over 2. So we have 1/2, comma, square root of 3 over 2. Now that we have those points, we can actually create, we can find the values for all the points in all the other quadrants. So we'll do quadrant 2 together. This has the same y value, so it's square root of 3 over 2, but our x value is on the negative x-axis. So this is negative 1/2, comma, square root of 3 over 2. For this point, same thing, same y value, but negative x value. So this is negative square root of 2 over 2, comma, square root of 2 over 2. And lastly, for quadrant 2, this point, same y value, opposite x value, negative square root of 3 over 2, comma, 1/2. Okay, now the same thing goes for the quadrants 3 and 4. You can find the values of those points by looking at this. We'll have the same x value, but opposite y values. So this will be negative square root of 3/2, comma, negative 1/2. Oops, 1/2. Negative 1/2. Okay? And then I'll do one in quadrant 4 as well. We'll do, for example, the 45-degree angle in quadrant 4. So here we had square root of 2 over 2, comma, square root of 2 over 2. Same x value, but opposite y value. Square root of 2 over 2, comma, negative square root of 2 over 2. Okay, so that's it for the construction of the unit circle. The other part of this construction is making our graph of sine. Okay, and this is what we'll do in class. So I'm going to show you how we'll do it in class, and that is to use spaghetti noodles to measure our values on our unit circle. So sine of theta is the y value. Okay, so what we're doing is we're measuring our y values. So we'll take a piece of spaghetti. Now on our first point, on when theta is 0, we're on the x-axis, so our y value is 0. And then at our 30-degree angle, our y value is that piece of spaghetti there. And then we move on to our 45-degree angle, our 60-degree angle, and they don't have to be exact, we're just estimating, and our 90-degree angle. And then we'll keep going around. So then we have our 120-degree angle, and so on. And we're going to do this for one full cycle. And then if you have extra spaghetti, you can keep going all the way around. You might be able to make it around twice, around the whole circle twice. Okay, so once you've measured all of your angles, we're going to go ahead and glue them onto this coordinate grid. Now, I'm hoping to put a full rotation in here, so I can't go by 1 degree because I only have 10 blocks. I can't go by 10 degrees because I would need 36 blocks to do a full rotation, right? So instead, we're going to go by 45 degrees. So this will be 45 degrees, 90 degrees, and so on. Okay? And instead of x, we're going to call this theta. And then, using the glue stick, we're going to glue down our spaghetti. So first of all, at 0 there was no spaghetti. So our first piece of spaghetti goes at 30 degrees, which is a little bit closer to 45 degrees than 0. And then our next one goes at 45 degrees. And then 60 degrees, which is a little bit closer to 45 than 90. 90 degrees. Okay, and then 120. 135. 150. And then we get to 180. Now at 180, we were back at 0, right? Because at 180 degrees, we are on the x-axis, the negative x-axis, but our y value is 0. And then we keep going. But now our y's are negative. So hey, come on in. Okay, so now we have the graph of a full cycle of sine. We could keep going. We could keep going around the circle again here, or we could go around the circle backwards and populate it here. But the idea is to see that the pattern is that it goes up and it goes back down, and then it goes negative and it goes back up. And what we'll call this is we call this a cycloid or a sine function.